Okay, let's do a little integration by parts. Okay, integration by parts. Okay, so integration by parts. I'll just use purple. Now I'm gonna use blue. Okay, integration by parts. Okay, here it is. This is the formula, and let's discuss how to use the formula. Okay, say I got an integral, and say it is kind of nasty. So we get natural log of x. You know, it's pretty common. We see natural log of x a lot, and as it turns out, it's kind of tough to integrate. You know, no u substitution, no whatever. We're just going to use integration by parts on it. Okay, so first thing I want you to notice how this integral really has sort of two parts to it. Okay, it's got an ln x and then it's got a dx. And notice how up here in my formula I've got a little two-part guy. Okay? Well, what I'm going to do is I need to make some substitutions. So I need to pick what is u going to be. Okay, I'm going to choose a value for u. And that's sort of the good thing about integration by parts. It gives you freedom to choose. And I'm going to choose natural log of x. Oh, and by the way, this is a total trial and error type method, you know? Just like u substitution, it's very trial and error. So, let's see, I picked my u to correspond to this natural log of x. So dv can only be one other thing. I mean, it's got to be dx, doesn't it? Okay? Well, now notice over here I have a v and I have a u. Okay, so it looks like I'm going to need a du definitely. And that's pretty easy to find, because if I just take the derivative of this guy, you know, in its differential form, then I get du, don't I? Okay, and we know that's easy. That's 1 over x, and we're at dx, so it's in differential form. Okay, so let's see here. Now we've got we need a v though, don't we? We need a v. So I have dv. So if I take the integral of this guy, okay, integral of this guy, I get v, don't I? And this one's pretty easy to do. We can do this in our head. You know, this is x. Or wait, no, this is the integral of, yeah, it is x. Okay, so plus c, yeah, but we're not going to worry about that right now. Okay, so there we go. We got that. Okay, so now all we got to do is just fill in the blanks. Okay, so let me go down here. And our original integral was natural log x dx. Okay, and that's going to be equal to u times v minus integral of v du. So what do we got? U times v, that's x natural log x, minus integral of v du. Well, v was x, and see, du is equal to 1 over x dx. Right? Let me draw a little thing around here so we don't get ourselves confused. Okay, not a problem, right? Not bad. So let's see here. This will cancel out. That's pretty good. So we can go ahead and we could probably just go ahead and say this is equal to natural log x minus 1 dx. We don't really have to write the 1. That's just plain dx. And this is equal to x ln x. Let's see, minus x, and plus c, of course. You can factor it out if you want. It's totally optional. Doesn't matter to me. Okay, so that's pretty much what we did. Now, of course, this is a very easy one. You know, dv was equal to dx. You know, and it doesn't always work out this way. You will most likely see a whole bunch of calculus junk in front of some of these. So that's kind of where we'll go. But this is the basic idea, and in the next example, we're just going to get harder and harder, and I'm going to try my best to just give you some ideas about how to work with this, and it should at least point you in the right direction, okay? So that is integration by parts, okay? And, oh, and you know, we'll even explore this formula and where it comes from, because it's just, it's neato, you know? It's, well, I don't know, it's not really neato, but it's, you might be tested over it, so I better make a video just in case you don't understand it. Alright, well, I'll see you in the next video when we do more integration by parts.